Howdy, everybody. Let's do the long-awaited mole concept video. All right, so remember that the mole concept is just telling you how we group atoms together. Now, remember that we have Avogadro's number, right? And that is 6.02 times 10 to the 23rd, either atoms, like it says right here, or diatomic chlorine has molecules, formula units, or also molecules as well. So you can substitute atoms, ions, molecules, formula units, all sorts of things in here. Now, formula unit, by the way, is since we call covalent bonds molecules, we call ionic bonds formula units. They're the same thing, just if it's a covalent or ionic. Now, this is 1 mole, right? That's how we group them together so we can actually count them because atoms are super tiny. Now, there's a little bit of shorthand IB likes to use, and I like to use it too. When I say N for number, A for Avogadro, so that's an N sub A, that is 6.02 times 10 to the 23rd. All right, just substitute that number in there. That's a lot easier than writing it out. So let's do examples. How many moles are in 8.49 times 10 to the 27 atoms of molybdenum? That is just a single element, so I'll just take 8.49 times 10 to the 27 atoms. Use my dimensional analysis to convert atoms into moles. Remember, you want to cancel those atoms, so you put those down on bottom, and then put your Avogadro's number. That's how many atoms are in 1 mole, and we will end up with a nice even number of 1.41 times 10 to the 4th moles. All right, how many moles are in molecules are in 4.35 moles of SO3? 4.35 moles. Let's go the other way now. Let's change moles into molecules. And there are Avogadro's number of molecules in 1 mole. And so we get that. So the answer should start to make sense if you really think about it. A mole is a grouped term, but if you want to break it down into singular molecules, you're going to end up with a huge number. Typically, when you end up with moles, you end up with a smaller number like this. Not usually, that usually isn't the case. So how many atoms are in the sample above? Okay, so SO3 has, let's say it's got sulfur right here, and it's got 3 oxygens. So there are 4 total atoms per SO3. So what I'm going to do is I'm going to take this number, 2.62 times 10 to the 24, and multiply it by 4. And so that will give us 1.05 times 10 to the 25 atoms. Okay, so molar mass. So now we've figured out how to change moles to atoms and all that stuff. But molar mass is about using a real value that we can measure, right, out of the balance. So we use grams, right? And make sure you understand that, molar mass is found on the periodic table. So what is the molar mass of boron? Well, just look it up on the periodic table, and it's 10.811 grams per mole. Okay, or you could just say 10.8, maybe round up to 11. Nobody really cares. The molar mass is sucrose. See, now we have carbon. This is an organic compound, carbon, hydrogen, and oxygen. Those numbers round out very easily. So carbon's molar mass is 12, but there are 12 of them. So I'll multiply that number by 12. Hydrogen is 1, but there are 22 of them, so 22 times 1. And then there are 11 oxygen atoms, and oxygen is 16. You can go look at those up on the periodic table if you want. But that is necessary for you. You'll get those on all your tests. The molar mass of ammonium phosphide, well, ammonium is NH4, and then phosphide is just the phosphide, so it's just one singular phosphorus. So phosphorus has a 3 minus charge, ammonium has a plus charge. You crisscross them and you end up with NH4. That. So we have 3 ammoniums, 3 nitrogens, sorry. So nitrogen's molar mass is 14. We have 12 hydrogens. 3 times 4 is 12. So, and then we have phosphorus, which it roughly is about 31. Again, you'll see I'm rounding. The ones that are easy to round, I just go ahead and round them. Nobody really cares. Your IB grader is not going to care, and I'm not going to care. So the 283 grams of titanium, how many moles are in that? So we'll just change grams to moles. And the G stands for go to the periodic table to find the molar mass of titanium, which is 47.88 grams per mole. And so the grams cancel out. Very nice. And our moles is 5.91 moles. And that's a pretty typical answer. How many moles are in 19 grams of CO2? 19 grams CO2. Change grams to moles here. There are 44 grams of CO2 in 1 mole. So that makes it 0.43 moles of CO2. And the mass of 2.5076 times 10 to the 26 atoms of zinc. Okay. You'll see I put the atoms here, and then I put atoms down here to cancel out. There are Avogadro's number of atoms in a mole, and then I converted moles into grams. And so that will give us 2.7255 times 10 to the 4th grams of zinc. Simple enough. Let's do that back page, the last 3 ones. How many molecules are in 39 grams of water? So 39 grams of H2O. Grams to moles. So that's 18 grams per mole. And then moles to molecules this time. And there are Avogadro's number of molecules in a mole. So that ends up with 1.30 times 10 to the 24th molecules. How many hydrogen atoms are in 39 grams of water? Well, there's that many molecules of water, but for each molecule of water, there are 2 hydrogen atoms. So simply we can just take this number and multiply by 2. You don't have to show your work for the whole thing, your whole thought process. It's pretty typical for them to ask you questions like that or that build on each other. And just as long as you show it for the first one, the second one's fine. So how many formula units are in sodium chloride? So sodium chloride is NaCl. Now remember I said a formula unit is like a molecule. Molecules for covalent bonds, formula units are for ionic bonds. So there is 1 formula unit here. Okay? Now, how many ions are for this? Well, remember that if you put salt in water, it will split up into its ions, right? So there are 2 ions. Okay? Just so you know. All right, that's going to be it, guys. Thank y'all.